In this screencast, we will consider mineral resources and how the extraction of those resources, the processing or refining of those resources, and the use of those resources can negatively affect the environment and human health. So first, let's start with looking at the elemental composition of Earth's crust. Surprisingly, this is a pie chart of all of the different elements and the percentage of which they are represented in the Earth's crust. You can see that 46% is oxygen, 28% is silicon, and then there's smaller numbers here but still significant for aluminum, iron, magnesium, and calcium. And all of those other elements, if you remember the periodic table with many, many elements listed, all of those others together only constitute 5.6% of the crust. And any extraction of mineral resources that we do does take place from the crust. It doesn't even go deeper into the lithosphere, just the very surface of the Earth's crust. So that's a point to keep in mind, in that not only are resources not equally distributed on Earth, some of them on the Earth's surface are not even present in large numbers. Okay, we can classify mineral resources as being non-renewables, which include fossil fuels, coal and oil, metals, gold, aluminum, titanium, and non-metals such as sand and limestone. These non-renewable mineral resources may be found on the surface of the crust or deep underground, and that makes a difference. When something is on the surface, there may be more disturbance to the surface habitat and therefore more damage to that habitat. But sometimes if it's deep underground, it's more difficult to extract, more expensive, and if there are any mistakes, such as an oil spill, then the damage may also be great in that case. Okay, so when we have mineral resources, we go through the process of extracting, which means removing them from the crust, processing, which is can be refining, separating out certain elements from others, or simply refining the density of certain hydrocarbons, for example, and then using these resources. And all three of these steps affect the environment and human health. We're also going to keep in mind that the unequal distribution of mineral resources has social consequences. And let's take a look at how some mineral resources are used. So we can use mineral resources for energy. So for example, for the fossil fuels like coal and oil, they can be used for energy. Some of these resources may be used for building materials to build cars. So for example, the metals used to make a car, the roads, etc. Money is can be thought of in terms of things like gold, or the mineral resource on which it's based, but also, for example, for coins. Minerals can be used as semiconductors, so that's also important, an important use. Packaging, such as aluminum cans, and medical implants, such as titanium hips, might be used. So they have many varied and important uses by humans. Okay, now we're going to take our attention and focus on the way these materials are extracted, and that's called mining. The first so there are two main categories of mining: surface mining, where something is taken from the surface, and subsurface mining, where something is taken from deep within the ground. Now, surface mining can be further described by 4 different ways of removing material that are close to the surface. The first one is strip mining, and this is when certain elements like or certain minerals such as coal exist in strips or seams underneath soil, and to get to it, the first layer of soil can be stripped away, and then the next layer, the strip of coal, can be removed. And then there's another layer of soil beneath that, which gets removed, and then some more of the coal is removed. So let me take a look at that on the next slide, and we'll come back to this one. Okay, here's a picture of strip mining, and here you can see what would happen to this particular habitat. Even though it's on the surface, what might happen. So typically you would have a forest or other type of material above. That would all be deforested. Then a layer of soil called the high wall would be removed, and typically when it's removed, it is tossed away, basically down a mountain, sometimes blocking streams and rivers. And that may also bury other habitat. The giant machines come in and dig out the coal from this coal seam, deposit it in a container, which is removed. Then once that coal seam is exhausted, there's another section of soil called an overburden that needs to be removed, again, typically dumped aside, and then that seam is extracted. And then below that seam is some more overburden, another layer of coal, and then more overburden. So by the time you get down to the bottom, you actually have significant habitat destruction. Now I'm going to go back to the previous slide. So that was strip mining, removing a strip of soil and rock to expose ore, which is what you're after, in this case coal. And one of the problems, there are two main problems with that. One is the destruction of habitat, both at the site and when that overburden of soil is tossed away. It often blocks rivers and streams, or it's just piled on top of other habitat that might have been home to various plants and animals. A second type of surface mining is open pit mining. And it's exactly what it sounds like. A large pit or hole is dug in the ground, and it's completely visible from the surface, and this is typically the way copper is mined. So there is an open pit mine near Salt Lake City, Utah, that is 3 miles across and 1 mile deep. And that is so large it can be viewed from the International Space Station. A third type of surface mining is mountaintop removal. So it too is surprisingly exactly what it sounds like. So in mountaintop removal, you take some dynamite and blow off, this is typical for coal, you blow off the top of the mountain there to remove the top layer of soil to get to the first coal seam. And then you dig out the coal in that seam, and then you blow up some more and get to the next coal seam and the next coal seam. So I don't have a picture right here of what mountaintop removal looks like. It is the major way that coal is mined in the United States. It has significant damage to the habitat. You can try to put a mountain back together, but it's pretty hard to do. But there are regulations which are intended to have the mining company restore the mountain by putting the soil back and planting plants. But as you can imagine, putting back a mountain after it's been blown up is not that easy to do, and there are certain workarounds that many mining companies have done, which we'll talk about in a minute. Okay, the last type of surface mining is placer mining, and that's when someone searches for metals and stones in river sediments. So think of the old gold rush, when the gold rushers were out there with their sieves and would dig through the riverbed or let the water flow over it and see if they could find gold. Now, the vast majority of that gold has now already been mined, so placer mining is not something that is typically done today. Okay, on this slide we are going to look at the the types of mining we're going to talk about subsurface mining and then compare surface mining to subsurface mining. So when you have subsurface mining, it's typically done for coal. So you have a shaft built into the side of a mountain horizontally, and then a shaft dug down vertically into the mountain. And so a miner would enter the shaft and be lowered, dig out a seam of coal, and then go lower and dig out the next seam of coal, and then be lowered again and do the next seam of coal, etc. So if you compare that type of mining, which is typically done for coal, to surface mining, there is minimal dust at the site, but there are big earth-moving equipment, fossil fuels used to power this mining equipment, and it can be quite significant. On the surface, you have significant dust from earth moving, and you also have, again, a high use of fossil fuels. Now, if we look what happens with subsurface mining and we look at water contamination, when you have a subsurface mine, you have something called acid mine drainage, which is that as it rains and the rainwater percolates through an abandoned mine, the rainwater becomes even more acidic as it works its way through what remains behind in the mine. The various contaminants then can percolate through, particularly through the tailings, and can contaminate water and make it very acidic. On surface mining, you also have contamination of water that percolates through the tailings, the waste water as well. On subsurface mining, you don't have as much effect on soil. In surface mining, soil is physically removed from a site and often is left behind blocking streams and rivers, but occasionally may be reclaimed and have the mountain be put back together. When you look at subsurface mining, it involves a lot of road construction, which has the effect of fragmenting various habitats because these roads are built through to get to one mining site and then another. When you have surface mining, you do also have habitat alteration and destruction over the surface of the areas that are mined. And then what I would like to talk to further are the effects on humans. We have occupational hazards of being in a mine, possibility of death or chronic respiratory diseases such as black lung disease. And on surface mining, we don't have much effect on humans in terms of danger to the miner, but air quality and water quality can be and has been adversely affected near the mining operation. So I think this is a good place for me to stop for this screencast and move on to another.